Well, firstly, thanks for attending the presentation. This is going to be quite a simple presentation due to the fact that what we're presenting is how to simplify in-building coverage. So what does ZinWave do as a company? Well, what we do primarily is we make wireless work inside buildings. It's a unique solution where it's fiber only. We're the only guys in the world that actually have fiber to the antenna. So we have basically zero coax in our system, which obviously has a lot of advantages. The other huge advantage of a ZinWave solution is the one box that you buy is completely wideband. It covers every single frequency from 150 megahertz all the way up to 2.7 gig, 2,700 megahertz. So one installation, one piece of fiber and one small box will cover every single commercial frequency out there today up to 2.7 gig. That then leads to no upgrade costs, when you want to connect any new services. So for example, in the Middle East, where we are doing a lot of security systems, a lot of TETRA systems for airports, we don't care what frequencies you've got, what spacing you have, what your uplink, what your downlink, is it FDD, is it TDD? None of that matters. You put in a ZinWave solution and it works for everything. It's a small remote unit that actually sits at the antenna. So we have a, obviously, fiber cable all the way to the antenna where we have a small remote amplifier. And as I say, we cover every frequency for TETRA and P25 that's there in the world today. Just a little bit about ZinWave. We're owned by a large American company. Our primary market is distributed antenna systems for cellular, and as you can see from the pictures there, we cover everything from buildings to stadiums to airports to subways. And we have a lot of tier one companies that we work with. Apple is our cornerstone company. We are the global supplier to Apple for all DAS and Apple's buildings globally, which is quite an achievement to become a supplier of Apple. At the moment, we're working on the big spaceship that they're building in California, the big Steve Jobs legacy building. Just to give you an example of size, that's a $10 million project just for one building. We're approved by Nokia, and obviously a lot of the big mobile operators around the world use us, Verizon, the UK operators, Optus in Australia. And these are just a list of some of the projects that we've done. In the public safety sphere, we do a lot of airports, a lot of stadiums, and one of the other big security places where we put a lot of TETRA solutions is in casinos. We do a lot of MGM's buildings globally, Sands in Vegas. So, we do basically everything from mobile to security in all these projects. This is typically how a lot of TETRA and a lot of P25 systems are done today. And it's primarily amplifiers and coax cables that are put throughout the building. Now that works, and there's nothing wrong with that. There's obviously some limitations in the case of the building size. Once you reach a certain length of coax, you basically run out of usable signal. So that's one of the disadvantages. You could have issues with noise figure because loss in coax is equal to noise figure in the uplink, which leads to poor uplink performance. You could have unequal coverage where maybe you have certain feeder lengths going in one direction and certain in others. And once you've installed a passive system, to add to that passive system is pretty tricky because anything that you do to a passive system will affect what's already existing in the passive system. And the other big advantage is the size of the amplifiers. And just to give you a sort of idea, that filing cabinet is a typical size of remote units that you would buy from a lot of the other vendors out in the market. And a lot of these remotes that you buy will have 3 or 4 different frequency amplifiers inside them. And that's a limitation. With ZinWave, you can see the remotes are small, sort of the size, slightly bigger than an access point, but that covers every single frequency we discussed earlier. So you can see that, from a size perspective, and going to a building owner to try and install our equipment is a lot easier than trying to install these big amplifiers. And again, these are just some pictures of, coaxial installations, and you can see it becomes quite messy, quite tricky, and running big coaxes nowadays is not, it's not efficient, it's not cheap, whereas running a small piece of fiber cable is a much easier proposition. This is just a little block diagram of what we do. Obviously, all the signal goes into the hub at one end. It's fiber out to a secondary hub, and then that secondary hub connects out to the remote unit. The fiber between the units can be up to 6 kilometers in length. So effectively, you can go from a base station to an antenna that's 12 kilometers away with no loss. So in Doha, for example, we're doing Tetra inside tunnels. And that's what we do. We have a base station in the middle of the tunnel, and you can go 12 kilometers in one direction and 12 kilometers in another. And every 200 meters, we have one of these small remote units in an IP65 box going to back-to-back Omni back-to-back Yagis, and we're covering that tunnel with around neg 75, neg 85 minimum signal strength. And that's a really cheap, cost-effective way to do tunnels. A lot of people still go with the leaky feeder scenario, an uplink leaky feeder, a downlink, and there's nothing wrong with that. That works fine. But for certain systems, antennas and using our solution is just as good as, the leaky feeder solution. So that's basically how our solution looks. So, in a nutshell, I said this was going to be a simple presentation. There's not really a lot to say in the fact that it is. We only have 4 boxes. We only have 4 part numbers that we sell. We have a hub, we have a fiber module, and we have a remote, and that's basically all we have. You stick it into the building, you run a piece of fiber, you connect the boxes up, and any of these frequencies, any of these technologies will go through the system and come out the other end. So what does this mean to someone who purchases our system? The first thing it means is that there's no additional cost down the line. Like a lot of systems today, if you, for example, at Heathrow Airport, if you put in a system with high power amplifiers, if a year down the line you need to add new frequencies or new technologies, that means you have to add hardware, you have to upgrade the system. You might even have to change the rack because the rack's only designed for a certain amount of space. That costs a lot of money. With ZinWave, you don't have that. The other thing is, when you're doing upgrades, typically systems will go down overnight or they'll go off the air for a few weeks. Again, there's none of that with the ZinWave solution. As I say, no future hardware costs, no disruption, no mobilization issues. And we're the only DAS in the world. We've patented this amplifier, and we're the only amplifier in the world that can do FDD and TDD at the same time in the same box. Again, a lot of our competitors need separate modules and separate boxes to support the different technologies. We can do everything in the one box. This is just a little bit more of a detailed look at the solution. You have the hub solution, the service modules, the little RF unit that plugs into the back of that, and that's where you connect your RF source, whether it's a base station or whether it's an off-air repeater. And the other thing, we can support up to 15, 20 different base stations at the same time over the system. And what's missing in that picture is you have a sort of point of interface where you can combine all the different technologies externally to our system, and then you feed one RF source into our hub. And then it goes into the service module. The optical module is the module that connects into the front of the hub, and that connects out to the remote unit. So again, with only 4 parts, it's fast to deploy. There's low maintenance because you're not having to carry 100 different amplifiers or 100 different part numbers as spares. It's very simple to design. We can get floor plans for any type of building, whether it's an airport, casino, tunnel, and within 15 minutes we can give you a design and a price. That's how simple it is. Because it's fiber to the antenna and you're not having any coax in the system, we don't need to calculate losses or lengths of cable or anything. As long as the fiber cable is within 12 kilometers long, we can give you a design 15, 20 minutes and give you a price that's 100% accurate. So that saves a lot of time, because with coax solutions, again, you've got to send technicians to site, you've got to know where you can run the cable, you've got to know what floors you can drill holes in. Then you've got to calculate what length the coax is going to be. You need to calculate the splitters, couplers to get the EIRP at the antennas. With our solution, none of that matters. As long as you're within 12 kilometers, you know what power you're going to get at the antenna. So yeah, so as I said, very simple. So, again, using fiber has huge advantages. We're able to run probably 15 to 20 remotes worth of fiber in a night in a building. Down in Australia, we're doing a lot of stuff at the moment in the airports, and obviously we have to work, there's a very narrow window of working, say between 2 in the morning and like 5 in the morning. There's 3 hours we have each night. But we can install probably 15 to 20 antennas a night, whereas the coax guys are lucky if they can do 1 or 2, because they're wheeling in huge big drums of LDF 650 and LDF 750, and it's really difficult. Whereas we go in with pre-made fiber terminated fibers, just pull them through, even blow them through some of the conduits, so we can install stuff really fast. And what that means is obviously the cost of the installation, which in most DASs is probably 50 to 60% of the cost of the project, we can reduce that by 50 to 75%. So overall, if you've got a $100,000 project with coax, we can cut that by at least 25 to 30% just in installation alone. So again, using fiber, sometimes, most of the time, in fact, we don't have to put any new cable containment. And as I said, fiber optic cable, we can go much greater distances than what you can with the coax. Just a little bit more detail on the product, the hub, the modules, and the remote. One of the things I haven't spoken about on the remote, we've actually in the stage of launching a new remote that's got integrated Wi-Fi. And it's actually got high density Wi-Fi, not just a regular AP. We've integrated an access point that can actually transmit 3 2.4 gig channels from the same radio. It's a company based in Canada that's patented this technology, and actually, there's a few big companies licensing the technology, but they're able to transmit 3 simultaneous 2.4 gig channels from the same AP, which no one else can do. And what that means is, in a DAS environment, where typically one DAS antenna, you need 3 or 4 APs to give the same capacity and same coverage, we can actually do it now with a one-to-one relationship. So with the access point now built into the remote, when you install this solution, you not only get mobile coverage, you not only get your public safety coverage, but you also now can have a high-density Wi-Fi solution, all with one installation. So that actually makes a lot of sense, because now you're pulling one cable that does lots of different applications. With the Wi-Fi, we now have location-based services available as well. So with a server installed and some software loaded up, we can now give location-based capability inside a building. And because we're using less APs, obviously the triangulation and the accuracy goes down. But because we also have 3 PoE outputs on the remote, we can run little Wi-Fi beacons around to just give better granularity of the location-based capability. These are just some reference sites that we've done. We do a lot of stuff with CETA, the big airport guys, and typically it's Tetra systems for the airport, whether it's the baggage handling, whether it's the ground crew, whatever it is. But CETA is one of our big customers, and we do a lot of airports around the world with them. It's another airport we've done with CETA. And also we've done some, nuclear and hydroelectric plants where, this one's GSM and PMR. But we also do in America, we do a lot of stuff with little radiation detection systems. So anything that's RF can actually go over this system. It doesn't have to be wireless communication. Digital TV we've put through, We've even done wireless signals to these, what do you call them, advertisement sort of boards in shopping centres. Dosimeter, the measurement of the radiation in nuclear power plants, they can be sent over our solution. Radio paging systems, anything can be put over our solution. No, last slide is me. So I know that was a bit quick, but we are fairly simple and fairly straightforward in what we do, and we try not to overcomplicate things, because really it isn't complicated. You stick in some fiber, you stick in a little remotes, and then you get your wireless coverage all over the building or the airport or the tunnel. So that's what ZenWave does.
Thank you. There was a question before. You still have the question?
Two questions.
Yeah.
Sure.
So the remote radio units,
Yes.
they have an integrated antenna.
No. You have a.
Sorry, could you repeat the question? Probably not everybody heard it.
The question was, does it have an integrated unit? You can buy the remote with an integrated antenna on it, but we only do that for special cases. We've built that for Apple in 2 of their locations where they didn't want antennas showing. But typically we have small jumper cable going to the antenna, 2-meter jumper. Yeah. Yeah. Yes.
What about MIMO?
Yeah. We, at the moment for MIMO, MIMO capability. MIMO is when you have two separate RF paths all the way to the mobile. So what we do with MIMO is we would basically have a secondary remote unit that would go connect back to back. So we have 2 remote units in each location. But one of the things that we've done with Optus in Australia, and this is for cellular LTE MIMO, we're doing what's called interleaving MIMO, which means that if you have one antenna transmitting path A of MIMO, the next antenna would transmit path B. So you'd go A, B, A, B. And we did some measurements, and I can share them with you if you come to the booth. With SISO, we were getting 10 megabit throughput on the LTE solution. With interleaving MIMO, it went up to about 60 megabits. And with full MIMO, which is AB from each location, it only went up to about 85. So for 75% of the benefit of MIMO, it's actually no cost to do it with the interleaving solution. With coax, you can't actually do that, because that would mean you would have to be running 2 separate passive systems to all the antennas. So with the fiber, it's a lot easier and a lot cheaper to do.
My name's Andrew McStay. I'm from Bangor University.
Yes?
Can you tell me a little bit about the advertising work you've done?
Yeah, well, the advertising was in Westfield in Australia. They have Westfield are a global shopping mall. And they've got a solution where, I have to be a little bit careful how I say it, but it's targeted advertising. And when people log on to Westfield, they download an app and they give their details, and their IMEI number of their mobile is logged onto the Westfield system. When they walk through a Westfield mall and Westfield know where they are, the advertisement board in front of that person that they're walking towards, they can target adverts based on what that guy wants to see or what they think that guy wants to see. So if he's just been to the Nike store or looking at something, he didn't buy something, they can put some Adidas shoe or whatever in front of him. So they send the different adverts over the ZenWave system, they transmit the signals to the boards to change the picture. That's what I was talking about.
So if he was at Victoria's Secret yesterday,
Yeah, his wife would know. That'd be good, huh?
and then he went with his wife the next day.
Yeah.
Yeah.
Well, it's actually,
Privacy issues
yeah, it's actually interesting because Nike in the States have done microchips in the running shoe now. And if you walk past a Nike store in the US, in certain Westfield malls, you'll get an SMS on your phone saying that these shoes that you bought 14 months ago, if you bring them in, we'll refurbish them, give you new laces. And by the way, while you're in the store, they try and upsell you on stuff. So there's a lot of that stuff going on in the shopping centres now. So it's really cool.
Any other questions? I've got one. So from a public safety,
Yes.
public safety, emergency management, how are you seeing? I can see some huge applications here. So are you seeing that around the world?
Yeah, I mean, public safety in the last year and a half has really taken off. I think with all the security concerns globally, a lot of governments and a lot of large public, places like airports, like stadiums, they're seeing a huge demand now to have like ubiquitous, public safety coverage and car parks and places where typically they wouldn't have that. So we're getting a lot of traction just because we have a system that fits every frequency. A lot of our competitors have maybe a Tetra module, but it's at a certain frequency. Maybe it's at 380 to 410. And in Saudi and a lot of these countries, they have a lot of frequencies all over the place. No one really wants to build products for one-off solutions where our product fits all that. So we don't have to do anything. We just sell them that box and they can use it for anything. But yeah, we're seeing a huge increase in the demand for public safety and in places where typically before no one would care.
So you're based where?
Okay, so Zinwave's based in Cambridge. The technology comes out of Cambridge University originally. I actually run, I'm president international. I'm based in Hong Kong. We have an office in Cambridge and an office in San Jose and an office in Dallas, Texas. So our manufacturing plant is in Scotland, in Kelso. We're made by a company, Plextronics. They're, I think, number 9 or 10 CM in the world, contract manufacturer. We're about a $20 million company. We're not huge, but we're growing sort of 40-50% year on year. So we're doing okay.
Super. And your booth is where?
Booth is just outside here and maybe 30 meters that way. So you'll see us there.
Another round of applause.
Okay. Thank you.